Welcome back. This is the third video in a series that make up the introductory Arduino workshop. If you missed the previous video, navigate back to our Canvas page and take a look for part 2. In the previous video, we worked with hardware and software of the Arduino to learn how to control an LED on a digital Arduino pin and some troubleshooting techniques in the event that your circuit doesn't behave as you expected. That introduced you to the concept of outputs. In this video, we will explore the concept of inputs. The output device we worked with was the LED. Now, on the screen are a few examples of devices that can be used as inputs: flow meters, gas sensors, push buttons. The center item is a photocell, and we'll be using it in our exercise to understand how to take in information from the outside world to process in our Arduino. This is a photoresistor, sometimes called a photocell or a phototransistor, the key word being photo. It is a light-sensitive resistive element. It changes total resistance with respect to the amount of light exposed to its squiggly topside. The more light that it senses, the less resistive it becomes. The less light that it senses, the more resistive it becomes. We will be working with a 10,000 ohm photocell. My first question to you is, does this device act in what you would think of as a digital fashion? Remember, if I'm thinking digital, you should be thinking all or nothing. This signal is all, nothing, and everything in between. The signal is not digital. The opposite of digital, in our case, is analog. And when we are thinking analog, I want you to be thinking somewhere in between. Our previous instruction was digital write. We're working in analog, so our new instruction is going to be analog something. Previously, we were outputting information. Now we want to take in information. Our pin mode, instead of output, is going to be input, and the opposite of writing is read. The new instruction that is going to help us take in information from this photocell, it is analog read. Remove the previous LED circuit, and let's get started with the new piece of hardware. We're going to be hooking up this sensor in a way that allows us to notice a change in the amount of light the sensor is exposed to. To do so, the only thing we want in the circuit that can change is the photocell. Everything else needs to be constant. When we set up this circuit, we'll be using the constant 5-volt supply from the Arduino. Also, I'd like to introduce a multimeter to our arsenal of tools. We'll be using it to check voltage values. If you put both probes at the same point on any circuit, it'll read 0. The voltmeter tells you a difference in voltage between the two probes. If you take the multimeter and probe opposite sides of this resistor, then it will read 5 volts, because one probe is at 5 and the other is at 0, or ground, the difference of which is 5. Now, let's say that we add a second resistive element to the circuit in series with the first. So, 5 volts goes to resistor 1, through resistor 2, and down to ground. If you were to have two of the same value resistor, in our case, two 10,000 ohm resistive elements, then you know that the top value is 5 and the bottom value is 0. What would you guess the voltage reads at the middle, the point where the two resistors connect? It should read 2.5 volts. Now, if the second resistive element in the circuit is our photocell, and you make it very bright, the photocell will essentially act as just a wire with no resistance, which means that measuring the center of the two elements will measure 0, because that resistor is basically just a wire to ground. Let's hook up our circuit. First, bring 5 volts from the Arduino to the 10,000 ohm resistor. Next, ground from the Arduino to the photocell. Finally, connect between the photocell and resistor. Our Arduino will be standing in for our voltmeter. On our Arduino, do you see a selection of pins we haven't used yet? Under the power section is the analog in section. These pins are exclusively designed to be used with the analog read instruction. Pick one of those analog pins and connect it to the node connecting between the resistor and the photocell. The first step in building the hardware is to remove the previous circuit. Next, we need a photocell. We need a 10,000 ohm resistor to match the 10,000 ohm photocell and some jumper wires. Together with the breadboard, we can start assembling the circuit. I start by bending the leads of the resistor correctly, there we go, and placing them into separate rows on the breadboard, just like we did in the resistor LED circuit. Next is the photocell, which needs to be connected to one lead of the resistor and in a separate empty row on the breadboard. Once that's securely in place, double check and make sure that the leg of the photocell and the leg of the resistor are indeed in the same row, and then grab jumper cables to pull a 5-volt and ground signal from the Arduino. The 5-volt signal should go into the resistor, the ground signal should go into the photocell. Bring the Arduino back into the picture, and make sure that the red cable is plugged into the 5-volt line in the power header section. Make sure the black cable is plugged into the ground line in the power header section. Double check to make sure this is the case, because if it's off by one in either direction, your circuit will not work and potentially could damage your Arduino. Next, we need to take the signal from between the two components to the Arduino. So I've plugged this blue wire into the line on row 17 and into an analog pin on the Arduino UNO. Now that the hardware is ready, let's take a look at the code. To do so, let's start a brand new sketch. Remember, open file, new. In an empty new sketch, we can start with our brand new command. Remember, analog read. And within the parentheses goes whatever pin you selected on your Arduino. Since we are reading information, our pin mode needs to be an input. Alone, those instructions will read values from the photocell, but unless we can see them, they aren't terribly useful yet. So let's talk about communicating directly with the Arduino. Computers communicate with the Arduino using a USB cable. USB is Universal Serial Bus, meaning the communication is back and forth, one after another. In the code setup, we need to prepare the software to show what the board is sending to the computer using the instruction serial.begin 9600. Once the serial port is opened, the instruction within the loop is serial print ln. This means that the value will be printed to the serial monitor for us to see. Your setup code should now include pin mode and serial begin. The loop should read the instructions analog read and serial print new line. I recommend including a slight delay. Now, we need to combine these instructions so that the value you read is printed to the serial monitor. You can just plug the entire statement analog read of whatever pin you've selected into the serial print line command, but in an effort to make this value something you can use later, we recommend saving it before printing it. That way, it's able to be used in other commands. So I'm going to define an integer called value, and then use value in the serial print line command. So let's see how this looks within the Arduino IDE. In the void setup, I need to include the pin mode command as well as the serial.begin command to open the serial port to be able to use the serial monitor. That serial port has a reading value, a baud rate, which is why we include 9600 in the command serial.begin. Next task is to declare our value to store the readings from the analog pin on. So int value equals analog read of A2, and then to be able to print those to the serial monitor for us to see, we just take that value and plug it into the parentheses on the serial print line command. Including a delay slows the rate at which values are being displayed and regulates the noise that might come from rapid readings. Using keyboard shortcuts, I auto-format my code and compile by pressing the verify button. This will also prompt me to save my code, which I recommend. Once the code is saved, it will compile, and if everything aligns, the code is ready to be uploaded. Double check that the board and port are selected, and upload your code to your Arduino. Open the serial monitor and look at the values your Arduino is reading. What do they mean? What are their units? Do you remember what we were measuring with the multimeter earlier? Voltage. This value corresponds to a voltage between 0 and 5 volts. So then why are the numbers so high? Well, if you cover the sensor, reducing the light, increasing the resistance in the photocell, the numbers should increase. If the sensor is flooded with light, then the values should get close to 0 because resistance is very low. Now how could you determine the range of values for our Arduino? We know the bounds are ground and 5 volts. So if we plug the jumper, taking data from the circuit, into 5 volts, then we can find the maximum. And into ground, we can find the minimum. I did just that, and you can see on the serial monitor that numbers are constant at 1023. That is while A2 is reading on the constant 5 volt line. Now they're constant at 0. That's because the jumper was moved to read on ground. meaning that analog read converts any voltage between 0 and 5 volts linearly between 0 and 1023. Congratulations, you've made it. Give yourself a massive high five and treat yourself to a mental break. You've just finished the final exercise of our self-paced Arduino introductory workshop. Great job. Looking for a challenge? See if you can integrate the LED circuit from before with the light sensor circuit now. Use conditional coding to make a nightlight. If the sensor's covered, the LED should be on, and if it's uncovered, the LED should be off. You can find more information on our website, more resources through our team or SparkFun, or if you're a CU student, test your skills on our Canvas page quiz. Thank you so much for joining me through this self-paced Arduino educational workshop series. Spend some time experimenting and working with these concepts. Once you are comfortable with this content, look into our next workshop in the series, Arduino Motion, controlling motors and servos with Arduino. As always, if you have any questions, comments, concerns, or anxieties, don't hesitate to reach out. We'd love to hear from you.